So I'm going to talk about streaming first, and then I'll talk about streaming with Signalr, streaming with Web API, and streaming with Grpc. But we have to start with what streaming is and what streaming isn't. And for that, we're going to open up a console window, and I'm going to demonstrate what streaming is. Here's a spoiler alert. It doesn't have anything to do with system.io. System.io stream, system.io memory stream, network stream. That's not streaming. Those are tools in the .NET framework that will help you do things. Maybe streaming, maybe not, but they have nothing to do with what streaming is. Yeah, okay. Toolbox is empty. Yeah. All right, so I might be doing a little cutting and pasting here. So this is a document that I have that was adopted from a Blazor train talk that I did. I'll show you what Blazor train is. It's basically a YouTube show that I've been doing for the last couple of years. And this code, Signalr, here we go, Signalr, advanced Signalr, Signalr Streaming, episode 66. There's a link there to download the code. And that has everything that I'm going to show you right here. But we're going to start with this little console application. Okay. So this is we're going to start off very simply with a console application that calls this method get messages. I hope you can all see that. You can bump it up. Control plus doesn't want to work either. So we're calling this get messages, right? Get messages is going to return an IEnumerable of message. And message is a simple class that has a text string property. So we're going to use a loop, and we're going to create 3 messages, the text being hello, whatever the number is, 0, 1, 2. We're going to add those to a list of messages and return that list. Yep, this is the best way to start at 9 o'clock in the morning. We're going to ease into this. First, I'll just show the app running, and then we will walk through it. And this will be our base class, and you can see that, right? Hello 0, hello 1, hello 2, done. So if we put a breakpoint here, run this again, you should be able to do this in your mind by now. I'm going to press F11, create the new list of messages, iterate, yes, add 1, add 2, add 3, and return. And then we iterate again to show the messages in the console. 1, 2, 3. Okay. So streaming started in .NET 2.0. We had this ability to, instead of creating a list and returning the list, we could just say yield return message instead of going and waiting for them all to happen. So the first thing I'll do is, we'll do this again. Now I'm going to press F11, which in Visual Studio will step into get messages, right? It does not. It skips right over that because the compiler is smart enough to know, hey, this get messages is doing a yield return. So instead, we iterate once. So here we go. Messages. I get the first one. I wasn't doing F11. So F11, we get the second one. We go back for the third one. And now we have them all. See the difference? So we're skipping a level of iteration here. And that's the really important thing. Because, I mean, you think about it. When you create the data, you put it into a list, you return the list, you go back, you iterate through that list again. So this way, there's one iteration. Where we're calling it, we get one at a time. And that's what streaming is. And it's been in C# since .NET 2. So there's a new kid in town in C# 8 called Async Streaming. That's what I just did here. And this code uses a new async, async enumerable type. All right, so let's start at the top here. So async streaming uses the iterator pattern yield return with async. So before this, before C# 8, you could not have a get messages that was async that did yield return. All right, so without async enumerable, you can't do this. You can't do the iterator pattern with async. So that's the goodness that comes in C# 8. So because it's async, your UI can start working with the data as soon as it gets the first piece of it. And the benefit is perceived performance, because the user sees the first pieces of data first. And if you have a large set to show the user, they're going to see whatever they need to see right away. And they're not waiting for a big list to come. Right? So that's the goodness here. It's a pull operation and not a push. We've had Signalr Streaming for a while using the channels. And I'm going to show you that. But that's a push operation. So async streaming is a pull. We're asking for the data, we're getting the data. This is a key right here. It's not about performance, async streaming. It's not. In fact, your performance may degrade. It's about perceived performance and scalability. That's what we're after here. So now instead of doing for each, we're doing await for each. Await for each. var message in get messages. Get messages is that same method, but now it's using an async enumerable of message. So async enumerable is not a task, because in async world we use tasks. It's a value task. And value tasks, without going too far into the tech, a value task should be used whenever you want to return a lot of something. Every time you create a task, you're using memory in Gen 1, in the Gen 1 memory space. And so those have to be deallocated. But with a value task, it's much more lightweight and doesn't create any Gen 1 allocations. So async enumerable, you can think of it as, you don't have to say task of async enumerable because it is a task. It's a value task. So the signature is simply async enumerable of whatever you're returning. And then inside, you do a yield return. And that's it. So let's walk through this. We'll start right here. right? F11, F11, right? Just to have something async in here. Get our first message, yield return, back in the client, show it. Next message. Show it, etc. So a console app doesn't, really show off, this thing. So what we're really going to do is show you how to use this idea, use this async enumerable to return Signalr data, to return web API data, and the same data from grpc. Okay, so I'm starting with a Blazor server application called Server Signalr Streaming Demo. Still don't know what happened to my toolbox. Okay, no problem. And Signalr Streaming Demo is going to need a Signalr client. This is a Blazor server app, so it's going to be pretty easy to demo. Yeah. All right, so we need the ASP.NET Core Signalr client library, because even though Signalr is built into ASP.NET Core, it's just the server side that's built in. If we want to act as a client to call into a Signalr hub, we need this. And next, we got to make some changes to program CS. I've got some global usings in there, which are my new best friend. Our Signalr client, we're calling add Signalr right there, and with response compression, just so that we can get as much performance out of this as possible. And then we map the hub, Stream Hub, which I haven't done yet, to /Stream Hub. So let's add that. So Signalr Streaming has been around for a while, but it's been sort of they had to invent a new mechanism to do this. So they're using the channel mechanism, Signalr channels. And, well, you'll see the difference. I think the new way is much cleaner. Here's our Stream Hub. So if you're not familiar with Signalr Hubs, what this does is it acts as a sort of a single point, a single server, if you will, that clients can call into. And the magic of the hub is that it can then turn around and send messages to every other client that's connected to it. You could send messages to all clients, including the sender. You could just send a message back to the sender. You could send a message to all others. In other words, sort of a broadcast to every other client. And also, if you have the connection ID of a particular client, you could just send a private message to that user. And it uses WebSockets under the hood. So all port 80, all very easy to use. There's no configuration. And the clients can be anywhere. You could have JavaScript clients. You could have C# clients on any platform. Any type of application, mobile, web, you name it. All right, so we'll come back to the hub here. And I'll explain the code. Yeah, so we're going to use channels here, and this is just sort of explaining things. All right, so Blazor code. So this goes into imports Razor so that we can access it from our index page. And then here we go. Change index. Wait for everything to wake up. And yeah, I guess I can start with this code right here. So on initialized, async happens first. And what we're doing here is we're creating the connection with an absolute URL. Since it's all one application, it's no big deal. Stream Hub. We start the hub, and then we have our handlers for messages. So this one handles the message receive channel stream data. And I've got a field here called receive channel message. And I'm invoking state has changed. And another one, receive async stream data. This one is the channel version. This is the async version, but they do exactly the same thing. We'll get to those in a second. And what I guess I'm going to do is just run this to show you what it does. I think that makes it easier when you're looking at the code to sort of understand what you've seen first. And I'm going to create 2 windows here. Okay. So we're using the 2 methods that Signalr does streaming. One is a push and one is a pull. This one's a push, the get channel stream. And we're just receiving 10 numbers and then stopping. And the same over here. And these are completely independent of each other. The async stream works the same way. It does the same thing, but it does it with less code. And then we also have the ability in Signalr to stream from a client to the hub, and then the hub can turn around and push out the data to everyone else. So that's what we're doing here. One is using channels, and the other is using async. Okay? But they're doing the same thing. I don't know if you can see, but these fields are updating once a second. So basically, we're streaming to the hub. The hub turns around and sends data to everyone else. All right. Let's look at the hub first. So this is using channels. And channels are, as I said before, the old way to do streaming in Signalr. This is a method called getChannelStream, where we pass in a count and a delay. How many times do we want to, create a number? And what's the delay between them? And a cancellation token, which you can use to stop things. So first thing we're doing is creating a bounded channel. And again, this is all old stuff. You probably will never, if you've never done it by now, you probably won't. You'll be using the async. I just want to show you the difference. A bounded channel has a limit. So we're saying this is a channel that we're going to send 10 items. And it's of int, so 10 integers. Okay? And then we're calling this write items async and returning the reader. So write items async does the work. And we just have a loop. And we're calling writer.writeAsync with that number, and then delaying with await task delay. Right? So we're pushing data out to the client. Now, in contrast, let's look at the async enumerable, right? Now we're using C#8 async enumerable. And here we've got our count, and we're yield returning the number and delaying. So all in one small set of code. And again, it's a pull operation, not a push operation. So the client is in control of this. Just like when we did the console app and we called get messages and yield return returns the data, it's the same exact thing, except we've got, the internet between us now. Okay? So going to index razor, let's go here, and we've got our get channel stream for the first button. Let's look at what that looks like. All right, so we've got our channel message and the button text because we're going to stop it. So let's make sure we have a connection, and then we create a channel from the hub, right? Specifying we want to receive 10 consecutive ints, exactly 500 milliseconds apart. So this is actually calling stream as channel async on the hub. And that gives us a channel, and then we wait because the channel is pushing to us. We're waiting to read. And then we do a try read, and if we get some data, we're going to say, hey, we received this data and update. Okay? Now in contrast, here's the get async stream. We're going to connect. We're going to return a stream from the hub. Yep. And so that's an async enumerable of int. And then we're just awaiting for each, receiving the data, and calling state has changed. So a lot more simple. To go down to the sending, streaming channel from client to server, let's go there. So we're creating the channel. This is an unbounded channel because we're not going to stop until the user stops, right? So it's unbounded, doesn't have a limit. And it's with strings. So we're going to say upload stream to channel. And we also need a sort of a flag so that the user can set it to tell us to stop, right? Like a cancellation token, but different. And so when we set that, we're going to stop. So just going through a loop here and using the writer, the channel writer to write async, pushing to the server, right? In contrast, when we stream to the server, we're calling send to async, upload stream, and we're passing as an argument client stream data, which guess what? That's our async enumerable. And that is going to use, you guessed it, yield return. All right, so that's enough Signalr. I think you get it, that this is what streaming does, but the really dramatic result will be when we show using Web API and grpc. So I've got this existing demo that I wrote when I was testing grpc and the performance versus Web API. And I'll start with that. And what it does is I created this dummy data set of 5,000 person objects, with a couple of fields in there, just with, like the Latin word generator kind of thing, just so that we have some data. And then I tested it with Web API and using grpc. Now, grpc started as a way to do remote procedure calls for web services. For microservices. And, for server to server kind of thing. Because it's what is the fastest way I can communicate from this guy over to that guy. And it started at Google. But if you look up grpc on the web, and there's a section, what does it stand for? It stands for grpc remote procedure calls. So yeah, okay, but we know it used to stand for Google, right? But Google doesn't own it. So it's completely open source, and it's completely cross-platform. And so what they did is they created this language that was sort of platform agnostic, and a platform agnostic way to define classes, or messages, they call them, and services. And so then it's up to each platform to do code generation to implement those classes, however the platform does, and the services that are used to do the communication. So I'll show you one more time. I'll show you the code running, and then we'll go dissect it, and you can understand it. So remember, this one started just as a way to test the performance of gRPC versus Web API. So I simply have a website that downloads these 5,000 records using each method, and then measures the performance. So this one is the API. Now, here's the thing. We're probably not going to be going to get 5,000 records for our users, right? Raise your hand and repeat after me. I will not give the user 5,000 records. Yeah, okay. So, but it's a good test. So the second time, I don't know if you can see that, but it's 1,824 milliseconds or 1.8 seconds. The first time it was 2 something for the API. So you just have to, it's compiling and all that stuff. It's always going to be faster the second time. gRPC, whoa, 515 milliseconds. The second time, 331 milliseconds. Now you're thinking, hey, maybe I can return 5,000 records to my user if that's what they want and they pay me for it. And then I also just have a demo to get a random person with gRPC. So that is performance, but let's talk about streaming. So first of all, let me just show you what the data is here. We have our person class, which I don't actually have because when you use gRPC, it gets generated for you. So in gRPC, you've got a person message right here. So we've got an int ID, we've got a string first name, a last name, a bio, and a photo URL. So when you use this, behind the scenes will create the person class. And this is one of the issues with using gRPC is where are my models, right? You can only have one model called person. So this is generating it, and you don't really see it anymore. All right. Also notice the numbers. ID equals 1, first name equals 2, last name equals 3. Well, this is because gRPC uses a binary serialization protocol, and it's really tight. And it does things by ordinal, by position. It doesn't know names of things. It doesn't, like JSON, it doesn't have the names and the strings and things in there. It's all by ordinal. And for every gRPC request, every service endpoint, which is defined here with the service keyword, you've got one request message type and one reply message type, always. It's not as flexible as, say, Web API. But that's it. So we have a get all and we have a get person by ID. So get all people request is defined as an empty message, an empty class. It doesn't matter if you're not going to send anything, you still have to make an empty class even if there are no arguments. So this is the proto file in gRPC that is for the service. Now, here's the people service itself, which was generated by gRPC Web. And gRPC Web is a sort of an HTTP version of gRPC. So it wasn't until gRPC Web came around for .NET that we could use this in a client to call into a service. So that's what I'm using here, gRPC Web. And so remember, this is all generated. I didn't have to, oh, wait a second. No, people service wasn't generated. You do have to implement this, but it has to be based on people base. And all these methods are virtual. So you're overriding the methods, okay? So that's what we're doing here. Now, compare this with the person's controller in Web API. And in both of these, I'm using a person's manager, which I created. And in get all, we're just returning person's manager people. So the person's manager just wraps around that people.json file and just returns the whole thing as a list. Very, very simple. On the client side, I've got an API service for calling the web API. And here's my get all. You've probably seen this and done this a million times, but there it is. Get async persons, deserialize it to a list of person. But I'm calling the code for grpc directly. So what I'm doing here in index, my page, is I'm injecting the API service so I can call the API, and I'm injecting the people client, which gets generated for me by grpc. So test API. We create, we save the date time, right, as start time. We call get all, and then we calculate the elapsed time, and we have our result, which is just a string that says this many records returned in this many milliseconds. The grpc is pretty similar, except we're calling peopleclient.getAllAsync with a new getAllPeople request, which has nothing in it, remember? And then if that list is null, we do the same thing. We just test it. All right, so that is the code as it is. Let's add some streaming to it. And all this blah, blah, blah is what I just went over. All right, here we go. So we're looking at the proto file. Yeah, this is the class that gets created. So here we go. We're going to add to the person's controller on the API side an async stream endpoint. Guess what this is going to look like? Async enumerable. Right? Couldn't be easier in Web API. So we're getting all the people, and we're yield returning them one at a time. So now here's the service call from API service on the client. It's going to look like this. And yep, this is a little weird because I don't think that the JSON tools have caught up yet for all the streaming. This is what I had to do with Newtonsoft JSON. I created a Json Serializer. So I get my stream from getStreamAsync, and I guess I lied. I do use System.io stream in here, but you get the idea, right? That's not what streaming is. This is just to return some data. So now I'm creating a stream reader from that stream. And now because JSON treats a JSON string as a series of tokens, which are read one at a time, and there's 2 tokens that I have to ignore, start array and end array, before I can deserialize. And so that's what we're doing. And we're just getting one person at a time, and deserializing that without the start and end array tokens. Okay. Now over to grpc. Oh, now we're going to replace the contents of index razor. Yeah, let's do that. New demo. And we'll come back to you. Okay, so on the grpc side, we go to the proto file where the service is defined, and we're adding a new remote procedure call called getAllStream. And this time, instead of returning a people reply, which is essentially an array, right? Repeated is the generic protobuf word that defines an array or a collection. We're returning stream of person. All right, so this is the generic gRPC way to say, hey, we want to return a stream. And then, we add this to people service, because now when we compile, we've got a new virtual method in people service that we can override. That's the controller. Here's people service. Okay, so this is getAllStream, takes an all people request, and returns an iServerStreamWriter of person. So under the hood, this is all async enumerable, but it's wrapped up in gRPC speak. So you have a response stream and the server context. You can use if you want to. We're not using it here. And then we're writing to the response stream, which does the rest. That does all the yield returning and all of that. And then okay, so this is looking at the code. I think that's it. Yeah. All right, let's run it. So this demo is a little bit different. We're going to start with the performance aspect of retrieving 5,000 records via a standard API call versus an API stream, and via standard gRPC call versus a gRPC stream. And hopefully this will sort of cement in that it isn't about performance, right? It's about scalability. So here's the API again. This is the same as we had before. 2.4 seconds. The second time would be 1.8 seconds. Now the same thing as a stream. All right, 2.1 seconds and 2 seconds. So it's taking longer to retrieve all of them with the stream. Okay. The gRPC side is really dramatic. Look at this, 508 milliseconds, 314 milliseconds, but as a stream, a whole second, almost a second. So there's a 3 times performance degradation just to get the entire set with a stream. All right, but that's not what it's all about. So here's the money shot right here. And that is we're going to use counter, the counter page, to actually show the UI with the data as it's coming in. And I could go through the code and show you the code, but it's really simple. Because I have in counter, I have a list, a select, an HTML select, that shows only the first 20 records, okay? What we're going to do is start the timer, start streaming, get the first 20, and after the first 20, I'm going to update the UI. I'm going to call state has changed in Blazor, which is going to refresh. And we're going to continue every 100 records to update the UI to say we've got another 100 records, right? And as we're getting them, you're going to see the list. Well, you won't see the list grow, but you'll see the scroll bar get smaller, right? So let's just do the API stream first. Okay, 670 milliseconds to get the first 20. All right, let's do it again. In fact, let's clear this, come back, and do it again. That time, only 57 milliseconds to get the first 20. And look, I can scroll down, and as I'm scrolling, they're still coming in. Right? All right, now gRPC. 189 milliseconds to get the first 20. All right. So to the user, they just said, wow, I just downloaded 5,000 records. And by the time they move their mouse over to start scrolling, they're already there, right? Perceived performance. Let's try it again. 34 milliseconds to get the first 20 after it's been compiled once. So that shows the power of streaming right there. gRPC is more performant than Web API, number one. And number two, when you use it with streaming, it's the performance really shines, and especially, you know, for the user. So questions? Yeah. Well, in place of one, yeah. Yeah. Yeah, that's a great question. As a matter of fact, I don't even know if this is still working, but on my GitHub repo, I wrote a grpc generator. Let's see if it's on Blazor Train. I wrote a grpc generator. Now, grpc is in of itself a generator, but what happens if you have all these classes already set up, right? Yeah, generate your grpc layer. So check out episode 46 of Blazor Train. And the code, okay, yeah, it is downloading a zip file, but I also have that on GitHub somewhere. So yeah, generate your grpc layer, episode 46. And essentially, the idea is that if you already have classes, you already have a web API, and you've got a large, you know, code base, how do I convert that over to proto files? I said Porto files. Isn't that neat? I didn't even think of that. Proto files and services, and that's what I attempted to do with this grpc generator. Great question. Anyone else? Yeah. Yeah. Right. Yeah. Yeah. I don't, because they do the same thing, just in a different way. If you need the push feature of a channel for any reason, I guess that's one reason. But they do the same thing at the end of the day. But I never used the channel in production, so I don't have that perspective that someone else might have. But the only difference really is that channel is a push, async is a pull. And if for any reason you need the push architecture, yeah. Other questions? Yes, sir. Yeah. Yeah. Yes. Yeah. You have the same level of security in gRPC that you have in Web API. Yep. Absolutely. And you know, there's a guy here who knows more about gRPC and its internal workings than I do, and that's Mark Rendell. So yeah, because he basically built a WCF to gRPC, a converter. I think it's either a converter or it's a code generator or something like that. But anybody who has a large array of WCF services, he's figured out how to move those over to gRPC. Others? Coffee time? All right. Thank you very much.